My name is Michael Chang. I'm the Deputy Director of the Brooke Byers Institute for Sustainable Systems here at Georgia Tech. I want to welcome you all for coming, and especially on this beautiful day for choosing to come inside. It's just remarkable here. We have one and only one order of business today, and that is to recognize the honorees that we have appointed. Georgia Tech has appointed Brooke Byers professors. This is sort of the highest award or appointment that we can give to faculty that conduct research or teach in the field of sustainability at Georgia Tech. And it's quite an honor that we have 3 inaugural professors associated with that title. It's also quite remarkable when you can appoint 3 professors in one area. It's called a cluster hire or cluster appointment at some point, and there's things that you can do as a team that you can't do sort of individually. And so we look forward to seeing how these 3 grow and interact over the next 5, 10 years and beyond, very much in their long illustrious careers. So we are going to recognize them again at the end of this panel session. John Crittenden, the director of the Brooke Byers Institute for Sustainable Systems, will have a few nice words to say about our 3 honorees, as well as our benefactor, Mr. Brooke Byers, who is an alumnus of Georgia Tech and very generous and kind with his gifts. So he will, before we adjourn, before we leave into the reception or the party part of our event today, John will say a few words, and we also want to take what's somewhat we think will be unique, a group picture. Sort of, if you watch the Oscars, you sort of saw how the tweet that went around the world, right? The tweet that broke Twitter was sort of the group. We're going to take sort of a giant selfie with everybody. So, at the conclusion of the panel, we're going to sort of set up behind the screen here, and the panel up front here will turn to face the camera, and the rest of you will be in the picture as well. And so we'll put that out, and you'll be able to see all these beautiful faces that we can see from up here as well. So stay for that. When we're done, we will adjourn. We have the entire run of the upper floor of the Historic Academy of Medicine here. So we will set up drinks down at this end, and we'll have some sweet treats down at this end for you to enjoy. And I think as you also go out into this space, you'll notice that there are fabulous spaces for having small discussions. This is going to be a big discussion here this afternoon. And we told them earlier on to think of this as sort of the pre-cocktail hour, and maybe we should have put something other than water in their bottles to really get the conversation going. But we're going to think about this as what would happen, the kind of conversations they would have if they met at a cocktail party or at a coffee shop, sort of serendipitously, sort of just collided into each other. What would 2 very high-level professionals talk about in terms of sustainability? What's on their mind? What are they thinking right now? So there's no sort of set agenda today. There's not. It's not we're going to look at transportation and sustainability or water and sustainability or energy or anything like that. It's all on the board today. So whatever's important, and sort of we want to begin to see what those connections might be. Hopefully, this will just be the start of thousands more discussions. Little discussions, big discussions, leading to big actions and big successes as well. And if there's things that we can do to help sort of propagate that or advance that in some way, I hope you'll let us know as well. We are going to dispense with lengthy intros because most of them, to introduce them, it would require a lengthy introduction, and I think we'd use up all of our time if we did so. So our moderator will probably just give a brief discussion, but I encourage you, everybody's got Google in their pocket today, so if you're interested, look them up, and you'll see that they are every bit as fantastic as they appear to be today. The other thing I want to say is that not many of us have name tags on today. I think our last reminder to you this morning said to bring an old name tag, and I have them, but I even forgot mine today. So as you go out into the space and enjoy refreshments afterwards, I hope you'll take the time to sort of introduce yourself to each other and exchange business cards and greetings and well wishes and all those things that make for a more hospitable Atlanta. Finally, I want to introduce sort of our moderator today, and then she will introduce the other panelists as their time comes up. Diana Rivenberg, she is the CEO of Strategic Imperatives. This is a sustainable business consulting firm, formerly of New York, or still in New York, and also with offices here in the Atlanta area. Diana is also the author of a new book called The New Corporate Facts of Life. And this is a really neat book. It has a lot of success stories about sustainability that businesses have taken, a lot of them here in the Atlanta area, a lot of them with folks here on this panel today, sort of the industry folks at least. Diana names names, sort of tells the story, and puts a name to an action, and it's really neat. When you start to see this collection of work that's being done here in the Atlanta area, you realize how big we could be if we work together a little bit better. Courtesy of Novelis, everybody who's here today will leave with a copy of the book, Diana's new book, and if you'd like her to sign it, she'll be outside signing as well during the reception. So I encourage you to take that book and home and read it and share it and follow through on it. It's fantastic. Last thing I'd like to thank is this celebration today is actually courtesy of a grant through a foundation, money at Georgia Tech that we have, some monies that were collected in the name of Jean-Louis Chameau. And for those of you that have been at Georgia Tech for a long time, you know who Jean-Louis Chameau is. He was at one point the professor and chair of the School of Civil and Environmental Engineering, became the vice provost for research, became the dean of engineering, became the provost. And when the presidency didn't open up fast enough, we lost him to Caltech. And he was at Caltech for about a decade, and now he is the president of the King Abdullah University of Science and Technology in Saudi Arabia. So he's done very well for himself. When he left Georgia Tech, there was a fund that was started in his name because he was so instrumental to bringing sustainability here to Georgia Tech. And we are celebrating sort of his legacy today, as well as starting a new legacy through these Brooke-Byers professorships. So with that, let me turn it over to Diana Rivenberg, and she will get us started on this, what we hope to be a very interesting and unique conversation. Thank you.
Thank you, Michael. Well, I am delighted to be here. And as Michael said, the book covers a lot of different stories around how business and industry is rapidly transforming. What are those forces, and how is it shaping the direction we're going in? And I love the people who are on this panel, because every one of these organizations have participated in the research for the book. So we have folks here from UPS, CocaCola, Georgia Tech, and Novelis, and I'm very grateful for the organization's support in all areas during the research. And again, John, thank you to Novelis for sponsoring the book this afternoon. So let me introduce briefly our panelists. First, we have Bert Bross, from the Brooke-Byers Professor of Mechanical Engineering, and leader of the Sustainable Design and Manufacturing Laboratory here at Georgia Tech. All right, all of you try saying Bert Bross, Brooke-Byers Professor, and see how well you all do. The same. Marilyn Brown, a little bit easier there, all right, also named Brooke-Byers Professor, and she is a professor of public policy at Georgia Tech, and a distinguished visiting scientist at Oak Ridge National Laboratory, and a member of the board of directors at the Tennessee Valley Authority. John Crittenden, Hightower Chair, Georgia Research Alliance and eminent scholar, professor of civil and environmental engineering, and the director for the Brooke Byers Institute for Sustainable Systems here at Georgia Tech. Elsa Reichmanis, Brooke Byers professor of chemical and biomolecular engineering. You said that a lot better than I did. And director of the NSF Integrative Graduate Education and Research Traineeship Program on Nanomaterials for Energy Storage and Conversion here at Georgia Tech. She must be very smart. And then our corporate recruits, to my far left, we have John Gardner, who is the Vice President and Chief Sustainability Officer for Novelis. Novelis is one of the the largest provider of rolled aluminum products in the world, and they're doing some amazing work there. I have Steve Leffen here on my right, who is the Director for Global Sustainability for UPS. And you folks all know UPS, right? You probably all have family members who work there. And last but not least, we have Bruce Karras, who is the Vice President of Environment and Safety at CocaCola Refreshments, correct?
North America.
North America. All right. So, now that we've have everyone introduced, did I miss anyone? Then let's move on to some questions. As Michael said, we really like this to be an interactive dialogue. So if one of you says something interesting and someone else wants to jump in or ask a question or pop onto that, then please feel free. Don't wait for me to ask a question. But let me start it out with the corporate participants first and ask you what's really hot right now in sustainability issues. These could be environmental issues or social issues, but if you had to just identify the top 3 or 4 things that are affecting your organizations and your industries, what might they be? Steve, let me start with you at UPS.
Okay, so I would use the word balance if I had to put it to one word. And so there's social pressures, there's financial pressures, and there's this whole world of balance. There's a host of opportunities for us. We're in the transportation and logistics business, and so natural gas is one of the opportunities for us. There's a wealth of natural gas, and we've seized some opportunities. We've used natural gas for a long time. In our transportation network, we have those little brown trucks, we call them package cars. And so for over a decade, we've used compressed natural gas on a limited basis to move some of our packages. About 1,000 vehicles in the U.S. We've also used propane in Canada. Propane's better in Canada than it has been in the U.S. But most recently, we've gone to liquid natural gas. So there's an abundance of natural gas. If you talk to the oil companies, there's hundreds of years of natural gas within the domain of the U.S. If you can get your hands on it, you can manage it. It's very cost effective, cheaper than conventional gasoline and diesel. The emissions are better, and so we're seizing the moment. We're purchasing liquid natural gas. You can put it on the road. You can go from point A to point B. We have routes that go about 600 miles a day. And so we're putting thousands of trucks on the road with natural gas. So it's a balance in sustainability between environmental, social, and economic. And so that's one of many opportunities where it's a sustainability opportunity where those 3 pyramids of sustainability have a balance that looks right. And so we're moving forward. So that's one avenue of many that we are moving forward. In a leadership position, it's very difficult to do these things. And for energy security reasons, for environmental reasons, for economic reasons, we're making a leap.
Okay, great, thank you. Bruce, what about at CocaCola? What would you say are the top few issues?
Yeah, I think for us, obviously, water is a huge issue for us. It touches every product that we make one way or another. And I think what we're seeing now is more of an emergence globally of more of a closed-loop system for water. So imagine, if you would, an operation that will clean the inside of our tanks and piping, normally discharged to a municipality. But actually, the technology's here today where we could take that water, clean it up, and essentially bring it back to drinking water standards. Now, that's not something that is real common here yet, but as we look at the global system, that's becoming a bigger and bigger issue. So how do we close the loop on water? And I think another interesting aspect we're looking at now is the millennials. So we're where we sell product to people, but as millennials emerge, what we're seeing is a little bit different, how they look at sustainability attributes of products, companies, how well connected they are, and that they're very willing to comment on a particular product to their friends and relatives using social media. So that's something that we're watching very closely as well.
Positively or negatively?
Positively.
Right. Good. Good. Okay. John, how about at Novelis? What are the
Okay,
top issues there?
just to build on Steve and Bruce's comments, I'll try and give a manufacturing perspective. Many issues that I think are emerging in sustainability here and globally. Obviously, we've mentioned some of the social factors, health, food, poverty. Many of our stakeholders are in discussion about the world's rising population. We're heading towards 9 billion population, dwindling resources in many areas, lots of issues and discussion about how we can, as a society, we're going to cope and react to global warming and climate change. So all of those for us are big issues, and Bruce talked about closed loop. That's very important for us in metals, and we're trying to move our business to become a closed loop total system. So with aluminum, we're very fortunate, and we can recycle material time and time again infinitely back into its own product, exactly the same quality, with huge emissions and energy savings. So that's very interesting for us. So this concept of what's called the circular economy is something that is, I think, a big trend in sustainability, and I think we're going to see that emerging more and more over the next few years.
Okay, great. Thank you. Thank you. So, and moving from what's hot really now until looking into the future and thinking about what are those issues that are on the horizon that you have to invest in right now in order to be able to address them, because they could be huge challenges for your industry or present huge opportunities. So I know at UPS I've heard you do a lot of scenario planning. One of those scenarios is called, oil 200? What would happen if oil hit $200 a barrel?
So that's an interesting discussion. So you think of global supply chains, and so labor's a component of that, transportation's a component of that, manufacturing's a component of that. I mean, what do you do personally if the price of fuel goes up exponentially? You change your habits. Well, manufacturers think the same way, so do transport of goods. So at some point, the labor that's very cheap in Asia is outweighed by the cost of transportation. And although there are security issues cross-border Mexico, those issues that are maybe insurmountable now don't become such a challenge if oil's $150 a barrel or $200 a barrel. And so the issues that you may have in one place all of a sudden aren't as big of an issue when transportation costs go up. So the world isn't as big as it really seems, and technology evolves. That's why businesses are very, very careful about making very large investments over long term. When you look at return on invested capital, things change very rapidly. Technology changes, fuel prices change, transportation networks change, rules and regulations change, and so the price of energy has a material impact. Look at what natural gas has done to the energy picture for the next decade. It's had a material impact on what's going to happen in the world. We weren't talking about natural gas as an economy, 5 years ago. Look at what the picture is going to change for the U.S. It's going to have a material impact on manufacturing and transportation and so on. So the World Business Council on Sustainable Development, which is a group that we're a member of. In fact, their annual meeting is going to be in Atlanta in November this year, which Coke is a member, Novelis is joining, has a Vision 2050 that talks about 9 different disciplines on how the world is going to evolve from 7 billion people to 9 billion people, and they talk about all the different things that are going to have to happen as the world emerges in these economies.
So how different is this world of the future, 10, 20 years out? Is it very different? Is it incrementally different?
Well, it's very different. So certainly water is was mentioned. Water is taken for granted, and water can't be taken for granted in the future. Things that you throw away in the trash today are commodities that have to be reused, as was mentioned. Mobility is an issue. So what's going to happen is people are going to have to live in cities. And so when you look at global GDP, 75% of the global GDP is going to be with economies that are growing today. A lot of people, this is called the base of the pyramid, that economy is going to grow. So there's going to be a lot more people with a little money. They're going to have cell phones. A lot of them have cell phones today. They're going to have communication devices. Today they don't have addresses, but they're going to have a cell phone. They're going to need access. And so what's going to happen is they're going to move into the cities. And if we build cities today, tomorrow, the way we build cities today, there's going to be lots of problems.
Right.
So there's mobility problems, there's pollution problems, there's accidents, injury problems. So cities are going to have to be built differently because people are going to live in cities.
Right. Okay, great, thank you. John, what about Novelis? What does it look like in the future? Very different, and how so?
I think we're going to have to see a period of real substantive change in many areas of our lives. I think Steve's absolutely correct about urbanization and some of the big social changes that we'll see over the next few years. And I think 2 points that we'd build on the conversation of earlier that we need to be really starting to think about is not just individual companies looking at their own situation and within their own four walls. It's much more important. I think this is another sustainability trend, Diana, that there's much more discussion about looking at things on a life cycle or a holistic basis and looking throughout a product's complete life cycle. So industries in its supply chain, as well as sort of governments and other stakeholders, we need to get much more collaborative looking at the whole life cycle. And our resources and environmental footprint, we can no longer carry on the way we are on a sustainable basis. Big area for us right now is transportation. And we're working very hard with many of our supply chain partners and customers, looking at how the transportation sector, in particular automotive, can reduce their emissions and be much more fuel efficient. Steve mentioned looking at gas, and obviously lots of work going on electric and hybrid vehicles, which we're actively involved in. From our perspective, one of the big areas we can contribute and work very closely on is lightweighting, and we've been working very hard with academic institutions, including Georgia Tech, our customers, and a number of other folks on how we can take weight out of vehicles. We had a big success relatively recently. You might have seen the US's biggest selling vehicle, the Ford 150 truck, is moving to an all-aluminum basis, and that takes a third of the weight out of that truck and has great savings on energy and emissions.
Mm-hmm. Great. So yeah, when I was first introduced to Novelis, they were described as transforming the industry to become above-ground miners. So you're not, rather than trying to take resources from the earth and turn that into aluminum, it's getting the aluminum that's already in existence.
Yeah, so we historically fed our business, and we're about 3 million metric tons on a global basis. And we're probably going to move to about 4.5, 5 million over the next 5 or 6 years. Historically, we fed ourselves with about a third recycled content. So we've recycled about 40 billion beverage cans a year, for example. We're the world's biggest can recycler. so that a third of our feedstock came from recyclate. We felt to really substantive change and make a reduction of our footprint and also our customers and suppliers' footprint, including Bruce's CocaCola. If we move to 80% recycled content, so predominantly using recyclate, we can take out 10 million tons of greenhouse gases a year, 10 million tons, and halve our absolute carbon footprint while we're doubling the business.
Right.
So that's really exciting. Big challenge.
And that's an important point, that many of these organizations are saying, we're going to do this while we grow our business. So you're looking to do this while you double the business at Novelis.
From our perspective and the discussion we've had with many folks is just looking at efficiency basis is not enough. Society has to do things on an absolute basis. We need to make absolute reductions.
Okay. Bruce, how about a wonderful world of Coca-Cola?
Yeah, I think just to build, I think, on things that Steve and John already talked about, I think what I've seen in the last several years is a supply chain-wide view of sustainability is really emerging, and I think we're all having conversations with both suppliers and customers in a way that we haven't in years. And sustainability has been a great bridge. We do a lot with our retailers now. And that takes us into things like thinking about the life cycle analysis. I think a gap today that we'll start to see close is really around designing with the proper end in mind, to bring it right back around. And you think of all the products that we have today that once you're done with that use, that supply chain ends, everything we have here is built around a landfill, whether it's electronics, whether, whatever product. And we have constant discussions internally with our designers about how do we make the next generation of products be things that are completely recyclable, everything down to the label material. How can that be something that goes right back to the beginning? And it's not easy. I think we all find that depending on what sector we're in. I think the other piece we're working on that's sort of the big challenge for us is building a plant-based PET resin. And for us, there's been a lot of work to date. We've got a good portion of the PET molecule solved with, at least on the bench top, the rest of it we've been able to produce. But when you start to look at those types of innovations, it would remove us from using petroleum as a base, which I think would be a huge benefit. The challenge being that, and I run this with just about every innovation, the supply chain doesn't exist today to deliver it to market at scale that we need and at cost. So probably Steve and John have the same debates internally with our business side about trying to get through some of the hurdles to build out a supply chain to deliver a sustainable solution. So we're working on it quite a bit, and we've got all kinds of projections. And as the world changes with the cost of petroleum, those trigger different actions by your business side to move these things along.
Okay.
And that's such an important point. So often policies get ahead of what's right for the planet. And ethanol is a pretty good example of that. And so we have policies in the U.S. that promoted ethanol and took food out of people's mouth, changed the price of corn to an exorbitant level, took more energy to actually make the product than save the planet, used exorbitant amounts of water, which always need to be part of the calculation. I mean, 19% of the power in California is used to pump water. Now they're in a drought. So you can't leave water out of the equation when you're measuring impact to the earth. And so sometimes special interest, for one reason, and this happens in the government often, get in the way of a total, and it was mentioned in the last conversations here, get in the way of a total planetary global impact perspective. And if we're really going to move forward, and industry is more open to this than many governments, I think industry is very interested in getting a full perspective on what is the global impact holistically of this process. And that's so important that when we look at policies, we have that holistic input. So that we're not supporting the wrong thing.
So these are big, complex issues, and I've heard the term collaborative used a lot, where we seem to be shifting much more quickly towards this collaborative economy, where you're working with your suppliers, with your consumers, you're working with your competitors in many cases, just to come up with solutions two very big issues. And certainly there's a lot more collaborations going on between higher education and corporations as well. So let's move to higher education. And since you were mentioning public policy, I'm going to start with Dr. Marilyn Brown. And Marilyn, what are the top things that you're focused on in your research and in your work at Georgia Tech right now?
All right. Well, I often take a heretical view that I think we have a lot of technology and science already. What we have is a poor policy environment to make some of those good choices more available and to let them flourish. Thank you, Jean, for the great example of a good policy. That's with the Ford 150 truck, which has come in part because we now have a very stringent fuel economy standard heading our way toward 54 miles per gallon for our vehicles in a decade or more. So we need to always keep in mind what future policies might have in store for us. So I wanted to run through the comments, if I might, that were made just a moment ago in regard to what policies might overturn some of the what looks like the best bet today. So we'll start with, say, LNG. Now, what happens if in a few years we open up our markets to export LNG and the price of natural gas domestically rises, doubles, triples? You know, we have a tremendous difference now between what we pay for gas, about a third what Europe pays, and that could disappear, that gap. What about oil? Now, what are we going to do with the Keystone Pipeline? Are we going to run out of oil and also be unable to pump it through pipes, or are we going to ship it through trains? And what happens when one of those 100-unit trains, explodes? Okay, so we have lots of issues there that can be dealt with to some extent through policy. Certainly, the Keystone construction infrastructure decision is a big one. Climate change, well, we really need to put a price on greenhouse gas emissions, right? And let the market respond and develop all those markets for products, many of which already exist, but they don't make sense because you can't get a return on your investment right now if it's strictly for a carbon reduction purpose. Let's see, water and the supply chain. CocaCola issues, of course, and all of us as well. Well, you know that every kilowatt hour of electricity contains within it a gallon or two of water consumption, so we've really got to figure out what to do with that. The Clean Air Act amendments, which will be released for public review probably in July, have in there some will probably, I don't know for sure, but I have a suspicion that they're working on some words about the consumption of water in power production and trying to prevent the tremendous waste that occurs with these open loop cycles. But really, it's the supply chain that I get excited about, because you're trying to get your retailers to become part of the solution, and I like to go all the way to the consumer and think about how we can empower this consumer who wants to be part of the solution through better information and through the right price signals, as an example, by getting electricity and paying for it with dynamic price signals that show you how much that electricity is costing every hour of the day, and giving you a better incentive to shift your consumption to those low price hours. So those are some of the things that I think about at night in terms of helping us to figure out how we're going to fuel the developing world, pull 1 billion people out of poverty, and not overheat the planet. It's a terrifying problem.
Okay, thank you. All right, Bert, let me ask you, what's going on in mechanical engineering? That's of great interest today in the sustainability world.
Well, mechanical engineering, as my chairman would say, is not your traditional mechanical engineering degree anymore.
No.
What I see happening now is, like, we heard a lot about supply chain already, the value chain. What we're working on, what's starting to happen next, is actually the industries and corporations starting to broaden. For example, we do a lot of work at Ford Motor Company. 2 years ago, they asked us, like, hey, we have these electric vehicles that charge up on the grid. They're sitting in a house. How about looking at the design of the house? And I see Dennis Kreis there from Southface, doing a lot of work on residences. So suddenly, Ford is starting to task us to say, like, hey, let's get Whirlpool in the room with appliances. Let's get SunPower in the room with photovoltaics, and Eaton, who provides power products, and see, can we make a whole that is bigger than the sum of the parts? And you see that a lot more. Now they've so like, again, think about a car company talking to an appliance company. There's no connection whatsoever, but yet they're talking about it because they've branded it now in a what they call My Energy Lifestyle, because they think like it's a lifestyle. A car in a mega city, you can't park it. You got to think differently. So they start looking at completely different business models. Some of you may have heard about the CMAX solar energy that actually was designed by those students right there. Raise your hand, guys. Those, come on, don't be shy. So they were at the Consumer Electronics Show. This is why I do a shout out for Georgia Tech, that they're hell of an engineers. But they basically did that because one hand is the company, like a Ford Motor Company, they don't have the expertise inside to sort of think about how can we get the car completely off the grid. Because the electric car is nice, but as Marilyn will say, coal-fired power plant, no, not good. So how can you get it off the grid? And how do you put concentrated solar on a car? Crazy idea, we don't know how yet exactly. We have some ideas, we can work it out. But again, you see that a company is starting to sort of get out of its traditional little silo of products and think about, if we start teaming up with AT&T, what could be possible from a consumer point of view with our drivers? Can we actually see what's happening and maybe provide a better product because now actually we know what they're going to do? So that's what I see, the big systems of systems.
So it's not just, Ford trying to figure out what's the next feature they put in their next vehicle, but what's the future of mobility?
Exactly. They do that too, by the way, because they still know, like, you have to sell cars right now, but they are looking down the road. If we hit 9 billion, there's not enough roads, not enough garages. How do we get a different business model? And what is the car part of it, or the vehicle?
All right, great.
I think that's a good connection. There's a book, I don't know if anybody's read, it's called Where Good Ideas Come From. It's about innovation. Steve Johnson wrote it. It's a fascinating read. And what it talks about is exactly the scenario you say with Ford and Whirlpool, where what we have to look at are the adjacent possibilities. So it might be getting people together that in the past were disparate businesses to look at what can we do together. And they give a lot of examples in that about how that's how we build ideas, and we need to do more of that. And I think that's where some of the things that we've talked about already with the supply chain being a little more connected is starting to help.
Great. All right. Elsa Reichmanis.
Yeah, so I think from the chemical engineering perspective, which includes chemistry and material science aspects, we're looking probably a little bit further away and from, in many respects, more of a future technologies where a lot of the global issues are driving a lot of the research that's ongoing right now from, if we look at energy, if we look at water, if we look at the food supply. And I think there's increasing recognition that solutions to all of those problems are going to be multidisciplinary, that they're not going to come from science and engineering alone. They're going to come from science and engineering working with policy, working with businesses in order to define what future technologies can be in place. I think there's an increasing focus on being able to develop sustainable material systems. When I was coming through school with a chemistry degree, we didn't really think about the reagents that we're using or the impact of the chemicals that we're using. I think today we're very much aware of what we're using and trying to minimize waste and think about where can we use renewable resources as opposed to looking at petroleum as the source for all of those substances. So what I'm seeing is much more of an interdisciplinary, multidisciplinary research focus. I think we're seeing an increase in working with policy experts and understanding how policy plays a role in materials design and development and implementation, and also how the business picture is going to play a role. So I see that approach continually increasing, particularly as we're educating our future scientists and engineers.
Okay, great, thank you. And John,
Oh.
what's happening at the Institute for Sustainable Systems?
Well, we're focusing on sustainable urban infrastructure, and I think I'd like to parrot what Bert was talking about with respect to looking at interactions. The largest machine, if you want to think of it that way, we've ever built would include the electrical, mechanical, and all the other issues that are involved in a city. That's the biggest thing we've ever done. And I think when it comes to products, like the Coke bottle, that's plant bottle and so on, we've done a lot of work in the area of environmentally responsible or sustainable design. But when it comes to cities, we haven't. And the big challenge is that once we develop the city the way we are currently doing it, predicated on cheap, abundant fossil-based fuels, that's a decision that lasts a very long time. So that decision, once you make it, how you're going to lay out the mobility networks and so on, it's going to be around for a long time. The problem is that the major impact is during the use phase. So once you've made that decision in terms of your plans, of your mobility network, water production, energy production, transportation networks, mobility, all of that, once that's laid out, you have to live with it for a long time. Now, the good news is I think in the not too distant future, well, we are slowly adding to our urban infrastructure, and so the objective would be to create this infrastructure that creates comfort and wealth, investing fewer resources, using fewer resources to maintain and power it in the long term. And so I think moving forward, there's a great opportunity starting today, moving 30 years or 40 years out, we might double the urban infrastructure that we have right now in the U.S. And in China, they might build residences for 400 million people, more than all the infrastructure we have in the United States. I hope they do it right, because it's a global place in terms of the pollution, demand on materials, and pricing, which is some of the things we've talked about here. So anyway, what we've been doing is focusing on what we call urban infrastructure ecology, looking at interactions between infrastructures. For example, I think Bert alluded to it, but he made some calculations that if we were to electrify all of Atlanta's personal transportation, we would need another 90 million gallons a day, and the domestic demand is 100 million gallons, so we double it. We don't have water for that. So we have to have different ways if we're going to electrify personal transportation than using the existing power generation facilities. Another thing is, as Bert pointed out, one of the problems with using renewables is they vary a lot. And so because of that variability, we have to have more spinning reserves. And so you can calculate what the benefits look like on a piece of paper. It might look really great to have more renewable feed in, but if you have to take into consideration the variability of the generation of electricity, you might have to have more spinning reserves, and this will have a dramatic impact on the benefit that you might get from renewables. So there's another example. And then water energy connections, as was pointed out here by Steve, 19% of electricity used in California is to pump water around. Well, nationwide it's about 4%. And there's also the reverse. If you use thermoelectric power plants in a centralized facility, why should we use heat to evaporate water? Why not use that heat for heating your buildings and the like? You know, I can point to places here in Atlanta where they're using combined heat and power, like the Perkins and Will building, where they basically have a furnace. That furnace creates heat, but also electricity. And they can use that heat to heat the building and also create cooling for the building. So depending on how that furnace looks like, you can also do it without water at all. And when it comes to power production in Atlanta, we use 5 times as much water for energy production than we do for domestic consumption. So if we could cut that in half, we could have a huge impact on the water demands that keep this city going. And so we've done some of those calculations. So I just gave you a few examples, the idea of water, energy, water transportation, and energy and water, and there's others. So I think I'll be quiet for a while, otherwise I'm going to get into a lecture. But those are the things that we're looking at as what we call infrastructure ecology, trying to look at all the infrastructures and how they're related to one another, and coming up with an optimal solution, looking at the interactions between those infrastructures.
Okay. Well, picking up off of the, some of the comments around collaborating and getting some ideas from across industries and sectors, what can happen, what should happen, what would you like to see happen between higher education and business and industry to really tap into the research minds, the thinking, the capacity at a place like Georgia Tech, and also bring that in with corporations like CocaCola, Novelis, and UPS?
So I like him.
You like him?
I like him. So I think one of the things is measurement. So we spend a lot of time on measurement. The WRI, the World Resource Institute, and WBCSD, which is the World Business Council on Sustainable Management, they're the ones that make the greenhouse gas protocol, very active in that. CDP, which used to be the Carbon Disclosure Project, now known as CDP, they have a voluntary mechanism for companies to report on carbon footprint of water and a number of forestry and a number of other things. Today, they measure individual companies' footprints, and they make a rendering on that. So in a world going from 7 billion people to 9 billion people, that measurement is on individual companies. But that's not going to get us where we need to be as a planet, because there are going to have to be some systems. What we need from a supply chain standpoint is we need optimal supply chains around the world to work together with each other. And it might mean that some supply chains actually have a bigger footprint, so that supply chains that aren't efficient don't exist any longer. And so somehow the measurement has to go from individual companies to systems that provide a lower global footprint, that have a systematic measurement, whether it be on a country basis, but it really has to be on a global basis, because right now there's too many individual measurements. It's never going to get us where we need to get as a planet.
So you're measuring what happens at UPS, Coca-Cola is measuring what they do, there are different industries that are measuring things?
Right.
And the United States is measuring what it's doing, as
Right.
is China, and we are not having a global measurement and monitoring system for the world. And that allows us to boast about how our CO2 emissions are reducing, have been for 4 or 5 years. And we're not consuming as much coal. We're just selling it. You know, we're selling it to Europe so they can go back onto coal. We need to close these loops. So we are very proud of what we do, but in fact, we're offshoring all the energy-intensive products that we buy. And that doesn't go into our calculus for country accounting. So we need students that can understand all of that and pull that together too.
Yes. So WRI understands that. Andrew Steer runs WRI. Peter Bacher runs the World Business Council, understands that. And they manage these processes, but it's very difficult.
Well, they don't manage the processes for country reporting.
No, they don't. But they manage those two organizations which make the greenhouse gas protocol through
And we can all learn from each other.
stakeholder engagement, and we can all learn from each other. And that's discussions that we have at the stakeholder meetings for the greenhouse gas protocol. So there's much to be done to have global measurements. You know, it's the example I always tell is there's a neighborhood with 50 people in it. They all drive their cars to and from work. And so you bring a bus into that neighborhood, tell everybody to get on the bus. So and they go to and from the neighborhood in the bus. What's the carbon story on that? The carbon footprint of the bus goes up. The carbon footprint to the planet goes down because everybody leaves their cars at home. So what do you want? You know, under the CDP, that bus company would be chastised because their footprint went up, but the planet benefits. So we have to think about that on a more holistic measurement on an LCA basis. If we're ever going to move and encourage, including on policy, how do we measure holistically to encourage the right behaviors? And that includes intensity metrics, not just absolute, so that we're measuring the right thing so we ultimately get absolute reductions as a plan.
So I think that also involves introducing other aspects to our education system. And I think it means educating students from the get-go to think holistically and think globally. Because most of our departments, most of our courses from when we first start school are largely stovepiped. They're not taught in a holistic manner where history, policy get incorporated into math and science and vice versa. And then when we get to the high school and college levels, we have chemistry, physics, biology, and then we have the sciences, we have the discrete engineering departments, the policy departments, the liberal arts, et cetera, when we get to the college university level. We have very few programs that cut across horizontally all of those different educational curricula, and I think we would benefit from looking at our education system and thinking about how we can build in more of a matrix-like approach so that we do have more of that cross-cutting education, so that we now build in a population that is going to start thinking more holistically so that it's easier to get to the end result that Steve was talking about.
There you go.
So Diana, as a business, where do we see Georgia Tech helping and making a contribution? Innovation for us and wider society is just absolutely vital, both for our process and our products, and how we collaborate with Georgia Tech and similar institutions is absolutely vital for our future. So we need to speed up on sustainability. We need more collaborative thinking. I think Georgia Tech is such a great institution to help us drive that. We desperately need that. The other area is as a global engineering innovation company, we desperately need smart engineers and technologists into our business, and that pipeline is very, very important for us. We recently opened our global R&D center in Kennesaw, just up the road. We're struggling to recruit high-level scientists and engineers into that organization because we can't find them.
So there are some smart students here who might be graduating soon who should see you
Absolutely.
get your business card. Okay.
Absolutely.
It's a good place to work.
Can I add something to that? I think what Elsa was saying is dead on. We need to sort of be careful with the stovepipes. On the other hand, people like Novelis, they also hire people because of their depth of discipline. We had a long time ago, and Mike remembers it for Jean Lechameau as well, the discussions about should we give a sustainability degree at Georgia Tech or not. At the end of the day, it came down to who's going to hire them. And traditionally, these companies will hire the mechanical engineer, the electrical engineer. But that doesn't mean that, Elsa said, we should have broadening a little bit. Most of and we're getting there slowly. In mechanical engineering, we actually opened up a curriculum to have at least to allow the undergrad students to have 15 credit hours of they can do whatever they want. They can take a minor in public policy. They can fill out for the IGOT program courses, etc. Just to broaden that perspective, because what we see is a lot of times when students come in from high school, when you tell them something, they believe it's true until you sort of make them forced to think about it and realize, oh my God, this is the biggest BS I've ever seen. And I'll point to you mentioned water.
Is that what that
measurement.
BS degree stands for?
Yeah. You know what the MS is?
I've got one of those.
More of that stuff. And the PhD is pile high deep. So that's the acronyms. But for example, you mentioned measurements and the BBISS and so on. And for example, one of my other students is working with a company on the global water tool, aqueduct, and looking at 4 different tools for assessing water. And guess what? If you put a plant, an automotive plant in a certain location, they all tell you different stories.
Absolutely.
And then you sort of said as a manufacturer and start to think about what should I do now? they're scratching their head and realize like, oh, this one doesn't have this data, this one doesn't have that data. So, but it's only when you start introducing the students to these kind of like uncertainties that they start realizing what they don't know and also realize what these companies and other people don't know. That's a big revelation, something that, oh, they don't know everything. Yeah, they don't know everything.
And to your point, and I'm an engineer, I usually apologize for that once a day, but my favorite thing to do in this space is forestry. And we do quite a bit of that. We commit to plant a million trees a year. We go up in the Boreal and we measure trees. We measured the trees. We support Fernbag. And that's a piece of this. There's a soft side to this, and it's understanding, you know, the water piece, the nature piece, the biodiversity piece, biomimicry. There's a business side of this, which is the money side of this, and there's a business case that's right in the middle. And you can't just stay on the left and talk about hugging trees, and you can't just stay on the right and talk about money. You have to be in the middle talking about business. But having engineers, and engineers don't always do that well, having them understand the forestry part of this is a very, very important part of this. Forestry is a great place to spend some time to get that piece of it, and many companies do that very well. It's very, very important for students to go get that exposure, because until you have that diversity of perspective, you really don't get the whole space.
We also need to have smarter governance and public policy makers that are working from fact-based principles and hopefully a deep understanding of the science and technology underpinnings of what they're what they are regulating or advising. You did mention in the bioenergy domain the problems over ethanol. That was a very big mistake, and all of us who are smart about energy policy knew it. And however, those who are in a federal government were unaware of the issues, apparently, or they're a lobbyist, you know, were in charge. I don't know. But we really do need to have, as you said, also in the interest of better integration across science, technology, and the economics and policy side to be able to provide better policymakers in the future.
You know, I think when I look at the question of, and I agree with the conversation so far, and if I have to look at it in practical terms, what does a university need to think about? And Elsa, as you talked about getting stovepipe, think about, since water is so close to us, all the water services in your home. Every one of them is a single pass application. So I'll go into a facility and they'll tell me a great story about how they're more efficient. They're more efficient at using it one time. And I think when you look at the global system now, where we have water scarcity emerging, right now we're dealing with the drought in California. It really begs for us to start thinking about how can we truly design our systems to operate in a new reality, so that the water that you use once can become gray water that's used in. None of our houses are piped for that. And so I run into that just with facilities. I think another piece that is good for students to be thinking about, when we build a production line, we'll buy a filler, we'll buy a palletizer, we'll buy various pieces of equipment, but we have to have somebody that's an integrator. How does it fit? And I think in the education that this institution provides, we need some thinking in terms of sustainability. How do we integrate it? So what do I mean? So if I buy a wind turbine, how many people are going to want to have a 150-foot wind turbine next to their house? And that's the kind of integration thinking that I think we need to have when we look at some of these innovations. There's a lot of great innovations out there, from solar to wind. But when you think about how does it integrate with what we have today, because that's the reality, it's not going to change overnight. We have to give some thought to fitting the pieces together. So, and I think that's probably tough in a curriculum to have that kind of work.
I think it's tough in a curriculum, but I think steps can be made towards at least having an awareness that there are other needs that need to be taken into consideration in development of a particular technology or facility, that, you know, a holistic view, not necessarily holistic training, because I think we do have to balance some of the more in-depth training, but we can have a generally more educated student coming out of school who does have at least an awareness of other issues that need to be taken into consideration. And, you know, almost sort of a life cycle analysis of, if we do this, what do we end up with when the technology or when the product or when the plant is no longer going to be used? And what happens along the way, and what do we do at the end of the day? So, you know, I think we can have a much more holistic approach, and we can, I think, be effective in the education curriculum, recognizing that there's a lot of learning that will still have to take place. And I think we can educate students to be more amenable to truly multidisciplinary team approaches to problem solving. And that's something which I think we don't do very well today.
One of the areas of integration that John, I was actually going to refer to something you said, is integrating, and then you can jump in again, integrating the supply side with the demand side, the producers with the consumers. I don't see enough of that in our educational system. So, for instance, it would be pertinent to both the water and the electricity challenges that we face. You mentioned if you've got intermittent renewable resources, you've got to back it up with some spinning reserves, which is probably going to be a natural gas turbine of some sort. Or it could be plugging people in to your electric system so that you can, with a reward system in place, drop their load incrementally. They may not even notice it, but they'll still be paid. So the lighting here turned down 10%, the temperature, I don't know, up or down. I'm not sure which way we'd want to go. But there's a lot that can be done by managing that demand side. And that does take a different kind of thinking. That's definitely cross boundary when it comes to disciplines. Because now you've got to understand the kind of response people make to different economic signals, different types of information, what they're most interested in, how to get their attention, whether they need to do it surreptitiously, or do they need to approve it each time? And how do you work these issues? And so that was a segue to you, because I know that's a favorite topic of yours, the demand side too.
Yeah, well, I was actually going to talk more about the holistic thinking. The example that I always like to give is transportation. Now, I don't want to pick on mechanical engineers, but suppose you were to talk to a mechanical engineer who designs cars, and the first thing out of your mouth was transportation. They would be down the track of reductionism, perhaps. Maybe they wouldn't, except for Bert. The reductionism being, well, I'm going to make my car more fuel efficient, more aerodynamic, lighter, and all that. But I say, whoa, back up for a moment. Transportation is access to function. Okay, so you tell me what function you need, then we'll talk about solutions to that function, how we might be able to provide that need, as opposed to it always has to be, you know, a movement in a personal car or something like this. So I just wanted to say that I call that more of a holistic view rather than a reductionist view. You'd be on the wrong track if you were thinking along the lines of about, you know, car mobility. I mean, right now we have 1 billion cars on this planet. How many can the planet sustain? 2 billion? How about 4? How about 8? There's going to be a limit, and that kind of segues back to the demand side of sustainability. We're going to have to do something really dramatic here if we're not going to exceed the Earth's ability to supply the resources that we need. And that segues perfectly into a material question with the big 5. Those are the ones that use energy: cement, iron, aluminum, and thermoplastics and paper. If you chart out into the future, 50 years into the future, the demand is going to increase by 50%. And even with the best scenarios in terms of energy, renewable energy incorporation, most efficient way to create those materials, guess what, folks? We're not going to meet our CO2 objective. It's just not going to happen. It can't be done. So that means we have to think about the demand side of sustainability.
Yeah, I would like, since he picked on me, so I got.
I'm sorry. I wasn't mean.
No, but he's absolutely right. I never forget, like we had, and this is again, enlightening students, opening their eyes. We had like many, many years ago, before natural gas, we had this is natural gas. We had a project with with Ford Motor Planning and Logistics. At that point, natural gas was so cheap that they actually were looking at like technologies for converting the diesel trucks to natural gas. And of course, they were approached by some crazy companies who said, oh, we have this hydrogen injection. We'll make you 10, 20% more efficient. We have propane injection. So we got Ford crazy enough to actually run a couple of big rigs with some of the technologies on it, and so like follow them around for a summer, intern up there, student, etc. And we're checking all these trucks out and all looking at, and one truck was going remarkably well. It was getting fuel economy improvements like you wouldn't believe how good for UPS. And then we started looking like, wait a minute, it doesn't have any of the technology on it. What's going on here? What's going on? And then the trucking company said, oh, that's Joe. Yeah, he's an experienced driver. Yeah, he knows how to shift well. What did Ford do? They sent all the drivers to school. They had a return on investment of 1 month by just simply telling them, like, drive efficiently, use this clutch, use this shifter, etc. We see the same thing right now with the electric vehicles, and Daniel there can attest to it. We have, on a full battery, the range is from 10 miles to 30 plus miles with a nominal speed 21. Now you get a 200, 300% swing in there in fuel economy just because of the person driving. And when it comes to like telling people what to do, my favorite saying, and I'm not going to pick on my wife, but like when I have to teach capstone design and they propose something, she's like, would my wife use that? And then you should see them think about, or would you use that? And then the 150-foot tall wind tower suddenly becomes like, I wouldn't want to use that in my backyard. So what would you use? And that suddenly puts it very personal. When you get people to think personal, they suddenly take ownership and they go, oh, yeah, that's a good idea technologically wise, but it wouldn't work because I wouldn't use it, my mother would use it, my grandma would use it. Bad idea.
So there are some realities here. One of the realities is it's estimated that the energy use in the next 20 years is going to go up 40%. And so when you add up, as mentioned, when you add up all the renewables, all the passive, it doesn't do it. Everything we know of, all the nuclear, everything we can get our hands on doesn't do it. So there's still going to be fossil fuels. The natural gas helps, but there is going to be a significant surge in the use of energy. There's a growing population that has demands in China, in India, in some emerging economies. They're growing very, very rapidly. They want TVs, they want houses, they want cars. They want everything that people that acquire wealth want.
But with that growing demand, I guess, Steve, that to meet John's point about climate change goals, that's not going to happen because society just can't meet both demand and supply and meet our carbon targets. So society, all of us, we're going to have to make some choices about what we want.
Right. So World Business Council talks about sustainable consumption, which is a big subject. So how's all that going to work? In Beijing today, it's 11 times the recommended level. Pollution, they have TVs now that shows the sun setting because they can't see the sun setting. And, there's some pretty big issues on the horizon here. One of the things we haven't talked about is the primary tenet of sustainability, which is transparency. And so today, like never before, there's social media and there's this notion. So if Mattel or some toy company has lead in their toy, you know about it very, very quickly. If somebody puts poison in your dog food and a bunch of people's dogs don't make it, you know about it very quickly. So that's a primary factor in this space, and consumers are acting more than they ever have before, and that's a major component of supply chain, and that affects governments, companies, this whole mechanism. And that's something we haven't discussed.
Yeah.
So a key part of the equation is not necessarily around innovation and technology and what exists and what can be created, but a key part of it would be around people. So it's the mindsets of consumers, the mindsets, the perspectives of people who are being educated right now, and how people collaborate to try and solve this. So it's more of a leadership issue, a collaboration issue, a mindset issue to help, because innovation comes in leaps and bounds, but it really we have to change in many other ways. About a year ago, I had a conversation with President Peterson, and he said, we're educating our students for jobs that don't exist yet, to tackle problems, that we have no solutions for yet. So it's really about trying to have students who are thinking critically, who can go out there and address problems as they crop up, and not just the ones we know about today. So, and one of the conversations that Michael Chang and I have had is around this strong need for corporations. When they ask about what they want in people working in sustainability, it's not necessarily that they have a particular expertise or a degree in a certain area, but that they have the ability to work collaboratively across functions and up and down level. So you've got the technician working with the engineer, working with the facilities manager, working with someone who's not in a technical area. So how do you teach your students today to solve the problems of tomorrow? You don't even know what they are.
Well, one thing we try to do is to engage everyone in that discussion, because we need everyone to be part of the solution. We don't want to lose half of the population because they're not properly educated. So we have very stringent goals at Georgia Tech for diversity of all sorts, not just the interdisciplinary type. I think that's really important because we've got to motivate the next generation. They don't all look like us.
Right.
So appreciating the different rules and ways that everyone makes decisions is important.
Yeah, and I guess we do want to change the face of engineering through sustainability, but we also want to change the faces of engineers as well. Because solutions that are going to be acceptable to our society have to come from a broad spectrum of initiatives and viewpoints. So I think you're right.
And I think it's important to recognize that society is global, and the world is getting smaller and smaller. And what may be a solution for our society may not be a solution for an emerging, developing society.
Right.
However, at least I believe for a business to be successful in the future, they are going to have to think globally and be able to address global demands. So that means that we need to be able to educate students to have that global perspective. And that means diversity in every sense of the word.
Yeah, I think one to add on there, I think how do you educate the students for problems that they don't know? Well, you give them the basic tool sets. The laws of thermodynamics haven't changed in many, many years. Math hasn't changed much. Still 1 + 1 is still 2. And those are basic foundations. But then you have to like Elson and everybody's alluding to, you have to tell them how to apply it. 1 and 1 = 2, but someone in India may not care about it. And so you have to bring a global perception in that, contextualize it, and help them understand how these tools actually can be used into new situations where they've never seen before, never thought of before, but hey, you draw control volume, ins and outs, and there's at least you have a starting point, you can start tackling the problem.
I wanted to take a slightly different direction, since we haven't been talking about the developing world directly. But I don't know if anyone's familiar with the idea that childhood mortality is related very strongly with population growth. To die young in Burundi is to die when you're 1. To die young in Sweden, you die when you're 63. So what happens is that in the developing world, because of poor sanitation and the like, where the childhood mortality is quite high, they have more children. Yes, a few die when they're young, but more live to be adults. And I think when we start talking about the challenges here that we've been talking about, we were talking about the golden billion. There might be another 8 billion out there by 2050 that are going to be needing and wanting the same things that we do. And it could even be bigger if we don't deal with this issue of sanitation. Because if we can, of course, there's two thorny problems there. One, you can't have a failed state, right? I mean, we can't do anything in that case. So the government has to be behind it. But the other is technological, and as a civil environmental engineer in the water field, we know how to deal with sanitation. So I just want to put that out there as we go forward. When we think about what goodwill we could create, it could be an awful lot if we could improve or reduce childhood mortality, and that would help us control population.
And one of the key things to that is educating girls.
And that's another part, of course. But if you just plot, you can see the plot of the childhood mortality. That education is always a part of it.
Absolutely.
Yeah.
Okay. I think we.
One of the things, if I could comment on with, it's a kind of a build off of having our students think globally. And one of the things I've run into in recent years, we have a certain lens here in Atlanta. We're an Atlanta-based company. We'll have a global commitment. But the question we have to start asking now, is this for the developed world or the undeveloped world? Because a lot of the solutions for one don't match the other.
Right.
And there's always an opportunity to really think carefully about that. I read about a lot of aid organizations supply infant incubators. And so if you take the incubator that we have here at the hospitals downtown, you send it to a third world country, once it breaks, it's done forever. And there was a really interesting innovation where somebody came back and really retooled it. So it did the same thing with car parts, because what they found is no matter where you are in the world, they know how to keep their Toyota pickup truck running. So the heat source is a sealed headlamp. Those are the kinds of skills that people will have to bring to the table. How do I solve a problem in the undeveloped world, but it's something that the developed world recognizes, and vice versa.
Right. Okay. Well, we have just a little under 10 minutes. I wonder if there are any questions from the audience that you might have for this esteemed panel. Dennis.
I'm always so impressed with the depth of wisdom we have in the academic community and in the business community in Atlanta. And I'm also depressed, I think, by the gulf I sense between that wisdom and policymakers at the state or regional level. Okay. And so how would y'all suggest we begin to bridge that gap?
So how do we bridge the gap between the impressive knowledge and skills and capabilities we have here and what the policymakers are doing in government? Okay. Panel.
Particularly in our hometown, our home region, and our home state.
Marilyn, why don't you start that one off?
It's a piece of cake. Well, I know the School of Public Policy at Georgia Tech has a requirement that if you're going to get your master's degree, you've got to spend your summer doing an internship. And the majority of those interns go either to Washington or to the state capitol, and they work on the staff of these decision makers. So I hope that they're helping to bring them that fact-based or science-based, systematic and integrating thinking. That's a really difficult way to do it one by one, but that's a beginning, and there's a lot of education that goes back to them at the same time to see how decisions really are made. If you want to influence decisions, sometimes it's not made on the floor of where the vote is taking.
No, absolutely not. So do they change careers after they have done those internships in some cases?
No, they do not.
Okay.
So, yeah, I think from perhaps a more science and engineering perspective, those of us who go into science and engineering generally don't get involved in the political sector, and we generally don't voice our opinions very much. So I think one thing that we could do is to work more effectively and interact much more effectively with our government leaders, either at the city, state, regional, or national level. That we could be participating a lot more than we are in that equation, and I think perhaps we might be able to train our students to be better at communicating not only with other scientists and engineers, but with the general population as a whole, and I think that could be useful.